So good morning. In this lecture we shall discuss about random number generation and random number generation techniques. So these are the contents I am going to discuss in this lecture video. See, first let us understand what is random number and the properties of random number and generation of pseudo random numbers, and what are the different techniques for generating a random numbers, and these contents we shall discuss in next video. So let us first understand what is the use of the random number. See, nowadays the random numbers are become the basic ingredient of every simulation system. So most of the computer languages have a subroutines, and they have implemented a object or standard functions. So those standard functions, objects and subroutines will generate a random number. So let us consider an example of OTP during online transaction or e-commerce purchases. So there what happens, a random number will be generated in terms of what here, OTP. So that OTP we could consider it as what here, the random number. So similarly simulation languages generate a random numbers that are used to generate event times and other random variables. So as we have seen already, the role of the random numbers in simulation of the systems. So we have already discussed the newspaper dealers problem. So there we have used the random numbers to find out what is a news day today, right? Similarly we have used random numbers in single checkout counter. So there the random number concept is used to find out the inter arrival time of the customer as well as the exact service time of the customer. So most of the simulation systems do require random numbers to find the particular event times, right? So let us discuss what are the properties of the random number. A sequence of random number, say R1, R2, so on, must have two important statistical properties. So every random number which is generated from the routine or subroutine or any function or any simulation languages, those must satisfy these two properties. The first property is uniformity and second one is independence. So every random number should be what here, uniform. They should not be what here, continuous. See, each random number Ri must be an independent, and sample drawn from the continuous uniform distribution between 0 and 1 is given by the probability density function as shown in this equation. So this equation will is what here, the probability density function for the random numbers which are generated between 0 to 1. So the x is what here, the random number. If it is less than 0 and if it is if it is greater than 1, so 0 and less than 1, then that number is considered as what here, 1 here, otherwise that is not considered. So this is what here, the probability density function for the random numbers between 0 and 1, and the expected value of each random number is given by this particular equation, and this is the variance of the random numbers. So some of the consequences which are related to the uniformity and independence properties are, say if the interval 0, 1 is divided into n classes or n sub intervals of equal length, then the expected number of the observation in each interval is given by what here, n divided, capital N divided by n here. So the capital N is nothing but what here, the total number of the observation. So let us consider we have a number between say 1 to 20. Okay, so we want to divide these 20 numbers of equal length, say for example 5, then 20 divided by 5 equal to 20 divided by 5 equal to 5 ones are 5 fours are 20 here. So in each interval we will be having what here, 4 observations. Okay, suppose if we divide the 20 numbers of say 10 intervals, so then we will get what here, 2 observation in each interval here. So this is one of the concept related to the consequences of uniformity and independence properties. The probability of observing a value in a particular interval is depend on the previous value drawn here. So this is what it indicates here, the probability of observing a value in a particular interval. So how much, what is the probability of having the numbers in next interval is depends upon what here, the previous values drawn, right. So these two are what here, some of the consequences related to uniformity and independence properties, right. So let us define the random number, pseudo random number. So pseudo means what here, false. See, a pseudo random number, so this is the numbers, the random numbers are called as pseudo random numbers because we generate a random numbers using what here, known techniques. So whatever the random numbers which are generated using known techniques will remove what here, the potential for the randomness, right. So that's why the random numbers which are generated by the known technique is called as what here, pseudo random number. But our goal is to generate or to have a random generator scheme to produce a sequence of the random numbers between 0 and 1 that simulate or imitates the ideal properties of the random number. Okay, so next we will discuss the sum of the general problems, some of the certain problems or errors that can occur during generation of random numbers. So the following are what here, different types of the errors which occurs during random number generation generator techniques. So the generated random numbers might not be uniformly distributed. So sometimes what happens, whatever the random numbers which are generated, those are not uniformly distributed. But the ideal property of the random number is to have a random number that must be what here, uniformly distributed. So they may be discrete value instead of continuous valued. So continuous uniformly distributed we should have from the random number generator. So let us make a clear here, the random number generator is nothing but it's a routine or it's a method which is going to produce what here, a set of or sequence of the random numbers. Okay, so here whatever the random number generator we will be having, no, sometimes it may produce what here, the random numbers which are not uniformly distributed. So the mean of the generated random number may be too high or too low. So this should not be there. The variance of the random numbers might be too high or too low. And last one is there might be a dependency. For example, there is a autocorrelation between a sequence of the random numbers. So autocorrelation means what here? The sequence of the numbers are dependent upon what here? The previous number. That is, there is a relationship between the first number and the second number, the second number and the the third number and the second number. So the random number should be what here? Completely random. There must not be any autocorrelation between the random numbers. So numbers successively higher or lower than the adjacent one. So this particular error will shows what here? The prediction of the random numbers. This should not be there. So several random numbers, several numbers above the mean followed by the several numbers below the mean. So all these are what here? The different errors or departures from the ideal properties of the randomness. So next we shall see some of the important considerations in random number generation routines. So during implementation of random number generation routines, we should consider some of the points here. So those are: the random number should be fast. Whatever the random number routine which we are going to implement in a programming or the method, that must be what here? Very fast here. So individual computers are inexpensive, but simulation could require many millions of the random numbers. So that's why it must be fast here. So when we start simulating a real world systems, there the millions of the random numbers are required within a short time. So in such a case, if the random number generator is not fast, if it is taking too much time for generating a random numbers, then that would not be useful. The second consideration is the routine should be portable to different computers and ideally to different programming languages. So whatever the generation technique, random number generation technique or a routine, that must be ported very easily to other computers in a hardware, or it can be shifted to any programming languages that can be ported. The routine should have a sufficient long cycle or cycle length or period uh, represent the length of the random number sequences before previous number begins to repeat. See, in case of random number, what happens? After certain time, the same numbers will be started repeating. So if we have a random number generator with a sufficient cycle length, after a long time the numbers will be start repeating. So we have to have a random number generator that should have what here? Long cycle length. The random number should be replicable, given that the starting point, it should be possible to generate the same set of the random numbers completely independent of the system that is being simulated. So it should be replicatable. Okay. And the random number generator should closely approximate to the statistical properties of the uniformity and independence. So whatever the random numbers, each and every random numbers generated from the random number generator technique, those should satisfy the ideal properties of the randomness. So they may ask a question: what is a pseudo random number and what are the problems that occur while generating a random numbers? So all these are what here, I repeat, all these are what here different problems occur during random number generation, and these are the some of the design considerations for designing a random number generator techniques. So now let us see what are the different techniques which are used for generating a random numbers. So we have three different techniques. The first one is linear congruental method, second one is combined congruental method, and third one is what here, random number streams. Yes, these three are what here different types of the random number generation techniques. So linear congruental method, combined congruental method, random number streams. So let us see what is meant by this linear congruental method. So this is proposed by Lehmer in 1951. So linear congruental method, LCM means what here? Linear congruental method. A linear congruental method produces a sequence of the integers, say x1, x2 between 0 and m minus 1 by using what here, following recursive equation. So this particular equation will produce a sequence of the random numbers from 0 to m minus 1. See, the equation is stated as follows: xi plus 1 means the first random number, this is equal to axi plus c mod m here. So where I equal to what here, 0, 1, 2, so on. So this is called as what here, seed, the initial value, and a is called as what here, the a is called as multiplier, and c is called as what here, increment, and m is called as what here, modulus operator. Okay, see, if c is not equal to 0, that is if this particular parameter is not equal to 0, then that form is called as what here, mixed congruental method. So when c equal to 0, then that particular method is called as what here, that particular generator is called as what here, multiplicative congruental method. Okay, so selection of values a, c, m and x naught affects the statistical properties and cycle length. See, whatever the values we choose for these parameters, so these values will affect the length of the cycle of a random number generator, and also the statistical properties, that is the independence and uniformity properties. Okay, and this particular formula will be used to generate a random number between 0 and 1. So that is Ri equal to xi divided by m. So these two formulas will use, see, this particular formula will be used to generate a random number between 0 to m minus 1, and this formula will be used to generate a random number between 0 to 1 here. Okay, so let us see, let us consider an example how to generate a random number between 0 to m minus 1 and 0 to 1. See, the problem statement is use the LCM, linear congruental method. So in case of C, let us see one more time. So if c is not equal to 0, then that is called as what here, mixed congruental method, nothing but linear congruental method. If c is equal to 0, then that is called as what here, multiplicative congruental method. Okay, yes, use LCM to generate a sequence of random numbers with x naught. See, x naught they have given, a they have given, and c they have given, and m they have given here. See here c value is what here? C value is not equal to 0. Then what would be the formula? The formula will be what here? X naught plus 1 equal to ai ai a into xi plus c mod m here. Okay. So x naught they have given as a what here? 27. So let us apply this formula recursively to generate a sequence of the random numbers, right? So x naught plus I equal to what here? 1. This is a x naught plus c mod m here. So a value is how much here? 17 into x naught value is how much here? 27, and the c value is 43 mod 100. So we will get a value 502 mod 100, right? The first random number is how much here? xi equal to 2. So we can find a random number between 0 to 1 by using this particular equation. That is, xi means what here? x1 nothing but 2 divided by what is the value of m? 100. So 0.02. So next we will find a second random number. So second random number. So what we do? The a is how much here? Yes, the a is just a minute. x2 is equal to what here? A is yeah, a is 17. So here this must come first here. A is 17 into what is x1? 2 plus 43. So this will be what here? 77. 77 divided by 100 is how much here? 0.77. So next x3 is how much here? This is what here? A. This is what here? x2. So here the third random number is what here? 52, and R3 is how much here? 0.52. So on. So on the random numbers will be generated. So x4 will be generated, x5 will be generated, so on till the repetition of the random numbers. See, consider this random number generator parameters, and you generate a random numbers between 0 to 1. So here seed is how much here? 45, constant multiplier is 21, increment is what here? 49, and modulus is how much here? 40. So use the same formula and generate a sequence of the random numbers. So there here they have mentioned you have to generate only 5 random numbers. Yes, again consider the same example is taken here, right? So in next section we shall discuss the concept of other two random number properties. So other than uniformity and independence properties, there are several secondary properties that must be considered. Okay, so these are maximum density and maximum period here. So the maximum density is meant that the value assumed by Ri, that is 1, 2, 3, leave no large gaps between 0 and 1. So the maximum density means what here? As much as possible the random numbers should be generated between 0 and 1. So there should not be large gaps between the first random number and the second random number, the second and the third random number, so on. So we have to construct a random number generator such that that particular generator should not leave large gaps between the numbers between particular range here. So to help or to achieve maximum density, and to avoid cycling in a particular applications, the generator should have a largest possible period here. So, largest possible period means, see, in case of every random number generator scheme, after generating some sequence of the random numbers, same numbers will be start repeating. So, till which numbers those will not be repeated. So, that particular length is called as what here, the possible period, that is called as possible period or cycle length. So, we have to choose a parameters for A, say A, seed and C and M, such that it should have a maximum uh, uh, period. Okay. So, in next section we shall discuss some other concepts which are related to the random number generator. So, hope you have understood this lecture video. So, please go through this video and practice these problems. If you have any doubt within this, you can contact me, right. Thank you.